Morning children, and today we'll be continuing with our topic integers, and today we'll be starting with multiplication of integers. Multiplication of integers, and in this we'll be seeing how integers are multiplied. So children, this is very simple. The product of integers is simply, for example, I have two integers 2 and 4, and if I multiply them, 2 into 4 equals to 8. Both the integers 2 and 4 are having the sign as plus, but if one of the integers, suppose if 2 becomes minus 2 and we multiply it with 4, then what will be the result? It will be minus 8. Okay, if 4 becomes minus 4, then minus 2 into minus 4, it will minus is plus, then it will be 8. And if it is 2 into minus 4, then again it is minus 8. So from here we can see that if both the signs are positive, then the result is positive. If both the signs are negative, then the result is positive. But if any one of the signs on the integers is negative, then the outcoming result is also negative, children. But there are some cases. Let us consider some more examples. Like if I have 1 into minus 1 into 1 into minus 1 into minus 1. What will be the result? 1 into minus 1, minus 1, minus 1 into 1, minus 1, minus 1 into minus 1, plus 1, and 1 into minus 1, the result is again minus 1. Let's put these in brackets to avoid any confusion. So from here we see that the number of negative times, that the negative sign is 3 times here, and 3 is a odd number. Acha, if you take one more example, same like this, but 1 minus 1 to 1 into minus 1 into 1 into minus 1 into minus 1. So how many times do we have the negative sign here? 1, 2, 3, 4. Let us check the result. 1 into minus 1, minus 1. 1 into minus 1, minus 1. 1 into minus 1, minus 1. Minus 1 into 1, minus 1. Minus 1 into minus 1, plus 1. 1 into 1, 1. 1 into minus 1, again minus 1. And minus 1 into minus 1, it will be 1. So from here we can observe, if the negative sign, if the number of negative sign is odd, then the result will be negative. But if the number of negative sign is even, then the result will be positive. So children, the product of two integers with the same sign is positive, and the product of two integers with opposite sign is negative. And from this result we can see that the final product is negative if minus sign appears an odd number of times in the product, and it is positive if the final product is positive if minus sign appears an even number of times in the product. Let us consider one more example, children. Minus 11 into minus 10 into minus 4 into 1. What will be the result? Minus minus plus, okay, plus minus minus. So we know this, that the outcome will be negative. So 11 into 10, okay, it will be 110, and 4 into 1, 4. So 110 into 4, it will be minus 440. So from counting the number of times the negative is coming in the multiplication, we can say that the final result will be positive or negative. If the number of times negative is odd, then the result will be negative. If the number of times the negative sign here is even, then the result will be positive. Okay, children? Okay, in your textbooks on page number 15, there is an example. The temperature drops 2 degrees Celsius every hour for 6 hours. What is the change in temperature? What will be the change in temperature, class? Change in temperature. This question is of your textbook, page number 15, example 6. The question is, the temperature drops 2 degrees Celsius every hour for 6 hours. So what is the change in temperature? So rate of change into number of hours. So what is the rate of change? 2 degrees Celsius. And what is the, how many hours it is dropping? For 6 hours. So 6 into 2 will be 12, but the temperature is dropping, so we'll put a minus sign here. So so if the change in temperature is 2 degrees Celsius, for every 6 hours the change in temperature will be minus 12, children. Now children, the next topic that we have is properties of multiplication of integers. Properties of multiplication of integers. So we have already discussed the properties for addition and subtraction. Now we are going to discuss it for the multiplication of integers. And integers are closed under multiplication. That means, children, if you multiply two integers, 6 into 12 equals to 12. So 12 is also an integer. 6 is an integer, 2 is an integer, and 12 is also an integer. If it is minus 4 into minus 3, minus 4 is an integer, 3 is an integer, it will be minus 12. If you multiply two negative numbers, minus 3 into minus 8, it will be 24. Still 24 is an integer. So children, integers are closed under multiplication. That means if you multiply two integers, then the result will also be an integer. Now children, we have the commutative property for integers. Commutative property. And how will we explain commutative property? It means A into B equals to B into A. That means ki if you multiply into two integers, 3 into 4, and if you multiply them like this, 4 into 3, the result will be the same. Both sides the answer will come 12. So integers are commutative under multiplication, and integers are also commutative under addition. We have already discussed that 3 plus 4 equals to 4 plus 3, 7 equals to 7. But integers are not commutative under subtraction. We can check from here. 3 minus 4 is equals to 4 minus 3. Is it equal? No. So integers are commutative for multiplication, addition, but they are not commutative under subtraction. Now the next property, children, we have is identity property. What is the property? Identity property. And in this property, it says that 1 is the multiplicative identity for integers. That means, children, if A is an integer, and if it is multiplied by 1, the number 1, then there will be no change in the integer. That means A into 1 equals to 1 into A equals to A. That is 3 into 1 equals to 1 into 3 equals to 3. So the identity property under multiplication for integers is A into 1 equals to 1 into A equals to A. That means if you multiply an integer with 1, then there will be no change in the value of the integer. Even if it is minus 3. And if you multiply it with 1, then the result would still be minus 3. Now, the next property that we have, children, is associative property for integers. And in associative property, how it works, it is simply, we have already discussed A into B into C. We've already discussed associative property in addition. But here we have multiplication. A into B into C equals to A into B into C. So if we put 2 into 3 into 4 equals to 2 into 3 into 4. So what will be the result here? 4 3s are 12, 12 2s are 24 equals to 24. So in associative property, children, for multiplication of integers, integers are associative. Under multiplication, integers are associative. This is your associative property. So integers follow closure property, commutative property, identity property, associative property, and the last property that we have, children, is distributive property. So children, the next property for multiplication of integers is distributive property. Distributive property. And distributive property for multiplication of integers is like A into B plus C. That means कि A into B plus A into C. Okay, so if we have 1 into 2 plus 3 equals to 1 into 2 plus 1 into 3. So what will the result here? 3 plus 2, 5, and 5 into 1, 5. Here 1 into 2, 2 plus 3 into 1, 3. The result is also 5. So for multiplication of integers, multiplication is distributive over addition. That means कि multiplication distributes over B and C. This A into B plus A into C. We will be looking the distributive property for multiplication of integers, but this time in subtraction. So A into B minus C will be A into B minus A into C. Now let us check the result. 1 into 2 minus 3 equals to 1 into 2 minus 1 into, let us check the result. 1 into 2 minus 3, the result will be 2 minus 3 minus 1 into 1, 1. And here 1 into 2, 2, minus 1 into 3, minus 3, and the result will also be minus 1. So integers, children, integers for multiplication follow closure property, commutative property, identity property, associative property, distributive property. Now children, the next topic that we have is division of integers. And children, we already know this, multiplication and division are inverse operation. So we can use multiplication to understand integer division. Let us look into this. Suppose we have two integers 5 and 6. And if I multiply 5 with 6, the result will be 30. If I divide 30 by 6, the result will be 5. 6 5s are 30. And if I divide 30 by 5, the result is 6. 5 6 are 30. So from this we can see here, children, that multiplication and division are inverse operations. How? 5 into 6 equals to 30. If we divide 30 by 6, we get the result 5, which we had in our multiplication. If we divide 30 by 5, we get the result 6, which was in our multiplication, which is 5 into 6 equals to 30. So children, division and multiplication are inverse operations. Okay, so now we will be looking into the properties of division of integers. And the first property that we had was closure property. And what does closure property means? That if we divide two integers, if we divide an integer with another integer, then the outcoming result would be an integer. Okay, let us check the property for division of integers. The first one is your closure property. Closure property. So let us take some integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose. So children, if we take 4 and divide it with 2, both are integers, the result will be 2. Okay. But if we take the number 4, but if we divide it with 3, so what will be the answer? It will come around 3 ones are 3, 3, 3, 3, and so on. So this number, this is a decimal, which is not an integer. So integers for division are not following closure property. That means if we divide two integers, then the result may not be an integer. In this case, it is a decimal which is non-terminating. If it would have been 5 divided by 2, the result would have been 2.5. Is this an integer? No, this is a decimal number. So integers are not closed under division. Now, the next property that we had was commutative property. And what was commutative property, children? That is key. A commutative property was, children? Yes. A divided B is equals to B divided by A. Let us check that integers follow commutative property under division. Suppose I have number, we had from we'll be selecting two numbers, 4 and 7. 4 divided by 7 is equals to 7 divided by 4. Is it going to be equal? No. So integers under division are not commutative. Integers are not closure. They are not commutative. Next property that we have, children, is associative property. Associative property. And children, associative property, which is A divided by B divided by C equals to A divided by B divided by C. Let us take three integers, 1, 2, and let us check the result. 1 divided by 2 divided by 3 equals to 1 divided by 2 divided by 3. So children, here 2 divided by 3, and then that result is dividing 1. Okay, and here 1 is divided by 2 and that result is divided by 3. So these two will also not be equal. Let us consider one more example for associative. Okay, let us take odd numbers so it would be easier for us. 3, 6, 9. These are not odd numbers, they are the multiples of 3. So it will be easier for us to divide. So 3 divides 6 divided by 9 equals to 3 divided by 6 divided by 9. So children, here 3 is divided by 6 is divided by 9 first. So 6 upon 9 will be 3 2 is 6, 3 3 is 9. So the result here will be 3 is divided by 2 upon 3. So 3 upon 2 into 3. Here children, what do we have? 3 is divided by 6. So it will be 1 upon 2 divided by 9. So it will be 1 upon 2 into 9. So what will be the result here children? 9 upon 2. And what about the result here? 1 upon 18. So children, these two numbers are not equal. So division for integers is not associative. So it is not closure, it is not distributive, it is not associative. So the next property for all integers that we have is if a is an integer and a is divided by 1, the result will be a. And if a is divided by minus 1, then the result will be minus a. So that means ki example 3 divided by 1, result will be 3. 3 divided by minus 1, the result will be minus 3. And the last property, or we call it the inequalities. And inequalities say that children, for all non-zero integers means ki 1, 2, 3, 4, 5, 6, 7 until infinity, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 until negative infinity. But we are not considering the 0 here. So if we have three integers a, b, c, and it says if a is greater than b, then a divided by c, a divided by c will be greater than b divided by c. And the other equality is if a is less than b, if a is less than b, then a divided by c will be less than b divided by c. Let us look at an example. In this case, a is greater than b. Take a 10 and b 5. So, and we can take c as 2. Okay. So, a divided by c, 10 divided by 2 is greater than b. What is the value of b? 5. 5 divided by 2. So 2 5s are 10. 5 is greater than 2.5. So if a is greater than b and a is divided by c and b is divided by c, still the result will be greater. A will be greater than b. And in this case, if a is less than b, let us take a as 5, b as 10 and c as 2. So 5 is divided by 2 is less than 10 divided by 2. So what will be the result here? 2.5. And here 5. So from these inequalities we say that if a is greater than b and they are divided by c, both a and b are divided by c, the result will still be a greater than b. The result of the division of a when it was divided, it came to some other integer, is still greater than the result obtained divided, greater than the result when b is divided by c. And here if a is less than b and it is divided by c, then the result here is a is less than b. So 5 is divided by 2, it is still less than 10 divided by 2. Still a is less than b. So if an integer is greater than another integer, the division will not change the result. If we divide it with an integer such as c, the result will still be A will be greater than B. We have some examples in your textbook, like 12 is greater than 10. So if we divide 12 by any number, let us consider 2. So 12 divided by 2 is greater than 10 divided by 2. The result will be 6, and here it will be 5. If we consider one more example, minus 12 is greater than minus 15. Yes, children, minus 12 will be greater than minus 15, because if we see this on a number line, because we have already discussed this, on a number line, if this is 0, then minus 1, minus 2, minus 3, minus 4. So minus 12 will be coming before, minus 12 will be coming before than minus 15. So minus 12 is greater than minus 15. So if it is divided by 3, minus 12 is divided by 3, and minus 15 is also divided by 3. The result here will be minus 4, and there will be minus 5. So here still minus 4 is greater than minus 5. So children, this ends the properties of division of integers. So children, this brings an end to our chapter, and in the next class I'll be discussing the exercises 1A, 1B and 1C. So please go over the topics clearly, which I have explained in the videos, and I'll be discussing the questions of the following exercises 1A, 1B, 1C. And if there are any doubts, you can leave in the comment sections. Thank you, class.